So let's go to Huygens and open the images under the chromatic aberration corrector. Chromatic aberration corrector directory under the demo images. And there are two files in there, wide field bead and wide field sample. So if you open these in Huygens and you click on the wide field sample, and you see if you look at one of the 3D renders, take for example the SFP render, you see that there is a misalignment. At least I know and I can tell you there is a misalignment. The red should be more overlapping with the green. And you've seen this picture before. Wouter already introduced you during the Decon Wizard demo that this image. So this is a kinetochore complex of a defining cell, kinetochore proteins. And if I render in higher mode, you see more detail of this. So all the renders show you clearly misalignment. Okay. So let's now fix this. And how to fix this? Of course, you can sometimes do that on your biological data if there's some correlation between the two channels, but this is dangerous, of course. This is that you assume that there should be an overlap. The best way is to measure something that you know. Take, for example, this bead. So in this bead, we also see the misalignment of this microscope. Green is clearly below the red. So let's go to the deconvolution menu and select chromatic aberration corrector. This pops up this window and shows you from the 3 different sides the bead. And we can play a bit around with these selections of the area. This is an orthogonal slicer, and you can watch if I move with this positioner, I can segment, slice through the bead. And I can do that in the different views. So the green slicer shows you the green window, and the red slicer shows you the red, and the blue shows you the blue window. Okay, so if we go here to the right, it says estimate chromatic aberration. You can estimate it from this image, from this bead image. You can also load a template to correct the misalignment, but we first need to estimate it. So we will do that. We select as a reference channel, channel 0. This is the first channel. And if you hover with your mouse over certain windows, you can get an explanation on the content. So there are different correction methods to choose from. We can apply a shift correction. The shift correction is correlation based, so it looks at the best overlap of objects of the signal between the different channels. You can apply a shift correction based on the center of mass. That means that in every channel, the center of mass of the intensities is measured, and then it tries to fit that. This can be a bit dangerous. Mostly the correlation works best, because the center of mass, if there's some chopping of signal, if the object is at the sides of the image, then the center of mass already changes. So it's a bit working less than a correlation method. Then we also have a full correction option, and this even corrects for not only for the shift in X, Y, and Z, but also degrees of rotation and even the scaling. So images may be different in terms of magnification, and that can be corrected for as well. So let's just now estimate, click on the estimate button, and we see that there is a vector created with these coordinates. This vector is projected in the different viewers. See? So you actually see what the correction will involve. And here there is a graph showing up with the shift in the alignment along the vector And here there is a slider, and we even can adjust this. So this is the default, so the old position, 0, 0, 0, and you see that the peak shifts in the graph. And we can set this, if we click on the blue dot, we can set this again to the estimated position. So we can do this for up to 32 channels. And you can select the channel you want to edit here. But we rely on the estimated aberration. We can save this to a template, which we will do. And I already made some templates, and I will make another one. And this is saved in my sales/SVI templates chromatic shift directory. Okay, so now we correct the beat, and let's see what this gives us. I hit OK. And close the tool. So now I have a corrected image here. And what I have included this still. This is not a perfect example. Why is that? Because this beat, you see that the red is still a bit misaligned with the green, and that is because if we look at the original data, the original beat, and open this in the twin slicer. And if we look at it from the side, compress it a bit, you don't need to really do this. You see that the red channel has been chopped off. There are just not enough set planes to include the complete red channel. So be aware of that. If you image beats, if you pick a beat to estimate the misalignment, that you really image the beat signal completely. Nevertheless, we continue with this, and we use this calibrated shift to correct for our biological sample. So now we go back to the deconvolution menu, and after selecting our cell, we click again on chromatic aberration correction, and we use the template that we made. So we load here the template, and now pick the one of today, 15th of April, load selected image. I can also go to the file manager, by the way, to load the file. I load the template. I see here the correct parameters, the same as what we had with the beat, and I say correct aberration. So now new image has been made, which is called the same, has the same name, but the additional extension of aligned units. So let's just now open this one in, for example, the surface render, different tool than I showed you before. And if we zoom in and look at channel 0, and now I make channel 0 same colors, so different objects can be having a different color, force them to become all red. Then in the second pipe, I select my other channel, which is blue, for example, and I show you here that the misalignment is corrected for. So every sausage-like structure has now 2 red ends. Okay, and we also see that in the SFP render here, if we click on the raw data, and then we can subsequently click on the corrected data, the chromatically corrected data, and we see that the shift is corrected. So, and this of course gives you a completely different picture in terms of co-localization analysis. So if in almost any image there is chromatic aberration, and the question is, how much do you want to correct that before doing any type of analysis? It would be good to just run them through the chromatic aberration corrector, see if you have a misalignment, and fix that.